All right, we're going to go ahead and start week 2 of quarter 4. So this week, similar, I'm going to walk you through the week 2 Google Doc through this video. It's not as long as last week's doc. Similar, you don't have to do it all at once, but don't put it off until the end. This week, your assignments that are due are the week 2 Google Doc and on AP Classroom, the Unit 5, rest of the multiple choice, so parts B and C. So the doc shouldn't be as long, but now you have 2 parts for multiple choice to do, so just make sure you're planning accordingly. These are all going to be due on Sunday at midnight. All right, so have your doc open. We're going to be structuring this similar to last week, where I'll go through some stuff, give you work time, then you're gonna come back and hit play, and so on. All right, so first question is asking you just to make a guess of the mean and a guess about the standard deviation. Not going to go over answers on this because we're guessing, but what I will remind you of is that 68% of the data of a normal distribution is going to fall right here within 1 standard deviation. So this would be 1 standard deviation away from the mean in both directions. And then similarly, that if we go 2 standard deviations away, we can make a similar statement. And that's going to be 95% of our data has to fit within 2 standard deviations. So use that to try to come up with your best estimate of the mean and standard deviations for this here distribution. All right. Hopefully your mean was, I don't know, somewhere around 170. And your standard deviation, let's see, if I want like roughly 2/3 of my data to fit within 1 standard deviation, I don't know, maybe like 10-ish. That looks like about 2/3 of my data would be fitting within there. And then if I go further out, that'll be 95%-ish of the data, just an estimate. Okay, here I'm going to ask you to take random samples of 5 students. In your doc, I didn't put this in my PowerPoint, but in your doc you do have a list of the 50 students and their heights. So I'm going to ask you to randomly choose 4 of them. You have a few options. On your calculator, you can go to Math, then go over to the PRB menu for probability, then go down to option 5, which is random integer, and hit enter. And then from there, it'll bring that command into your regular screen. So that'll look like randint. If you do 1, 50, 4, and then press enter, that'll give you 4 random numbers between 1 and 50. So you can do that. When I do that, let's see, I get 48, 37, 41, and 21. Those aren't my numbers I actually want to use. I'm going to have to go look at that chart. So like number 48, the height there is 164. For 37, it's 169. For 41, it's 182. And for 21, it's 168. So then I would go ahead and list these. You can use this one for one of them if you want to. If we were in class, I wouldn't let you because I would want to have a bunch of different data, but it's all good. And then I just have to find what's the mean out of those. So I'm going to add them all up. So 164, 169, 182, and 168, and divide that number by 4, and that would give me my mean of 170.75. I want you to go ahead and do this 3 or 4 more times so that this table is filled out. So all of you need to have 4 different samples and the means completed. All right, if we were in class, we would make a class dot plot. We're not, so I did this a bunch of times, similar to what I did last week. And I got this. I probably should have done more samples, but it was just really boring, so I just did 20 and stopped there. But I think it'll give us a good sense of what we're looking at. I want you to try to describe the distribution of this dot plot. So to talk to me about the variability, about the shape, center, and any outliers. When you're ready, hit play. All right, so for variability, without actually calculating it, there is a way to calculate the standard deviation. I'm not going to show you just yet. What I can see though is that like here, my data is mostly clumped up between like 160 and 178, whereas originally it was a much wider spread. Variability is describing how spread out is my data, so I can say that the variability is much smaller. Let's see, we can try to estimate it. So maybe I should try to do my center first. I would say that my center is still around the same place, 160, 168, 170. I'll still go with around 168. And then I want 65% of my data, or 68% of my data to fit within one standard deviation. So maybe like here to here. That looks like roughly 68% of my data. And so let's see, that's about a standard deviation of about 4. So for variability, I can say maybe it's about 4 centimeters. Remember earlier, I estimated around 10, so it is smaller. For the shape, I can say it's symmetric, unimodal. Well, it's not technically unimodal actually, because I have this one and this one. So I think if I would have done more samples, it would have become unimodal, but we can say bimodal for now. And outliers, not really. We don't really see anything that looks like super far away from other stuff. All right, for question 5, I want you to take a minute there. Hit play when you're ready. All right, so for the shapes, I'm going to go ahead and say the shapes are similar. Even though like this looks a lot more like, the first one looks a lot more closer to normal and this one looks a little bit more flat. Trust me, if I would have done more than 20 trials, the shapes would be a lot more similar. So that was just me not wanting to do more than 20 random samples, but you know, trust me, they should be similar if I did more. The centers are about the same. I got about 168 estimating and about 170 for the first one, so centers are similar. For what's different, the second dot plot is much less variable, has lower variability. All right, so that's actually it for like the intro activity, which went by pretty fast, a lot faster than some of that stuff we did last week. We're going to go ahead and take some notes. This will be in the notes doc as well, so don't feel like you have to write it down, but I am going to go ahead and explain it. When we're talking about the sampling distribution of X bar, and what this means is like we're taking a bunch of samples and we're finding the mean of each of those samples. So a few things I want to talk about. I want to talk about center, variability, and shape. Just gonna make sure I'm recording too. Okay, I think so. Hopefully my mic is on. All right, so to find the center of your sampling distribution, it's just equal to your original mean of the distribution, your population mean. To find the variability of your sampling distribution, you take the standard deviation of the population and divide it by the square root of your sample size. You'll get a chance to practice this. And then for shape, if the population is approximately normal, the sampling distribution will also be approximately normal. All right, so that's actually it for our notes for part 1. Please work through the check for understanding. I know there's probably the temptation just to like watch me do it, but like honestly, you're gonna learn so much more if you try it. Even if you make mistakes, it's all good, because then I'll go over it once you're ready. But I do want you to try all of the problems first. When you're ready, hit play and I'll walk you through it. All right, so for this check for understanding, and hopefully by this point you have tried it, otherwise shame on you, but you can still try it. Go ahead and pause, try your problems first. Here we go. Every day people watch 1 billion hours of videos on YouTube. This breaks down to every single person, watching YouTube videos for about 8.4 minutes per day. For US teens in any given day, the amount of time spent watching YouTube is approximately normal, with a mean of 18.5 minutes and standard deviation of 5.3. All right, so question A is asking you to find the probability that a randomly chosen US teen watches YouTube for more than 25 minutes in a given day. So with this, this is a sampling distribution, but our n value is just 1. Our sample size is just 1. We're just picking one kid. I'm going to go do my work up here because I didn't leave myself any space. All right. Because this is normal, we can go ahead and use our normal calculations to solve for this. Whenever you're doing that, I want you to get in the habit of sketching out a normal curve and labeling. So I've got 18.5 for my mean. And then when I label, just like I did last week, I'm going to label my mean, comma, standard deviation. And we're looking for what is the probability that if I choose one teenager, that it's going to be 25 minutes or more than 25 minutes per day. I like to use normal CDF for this. And this should be pretty straightforward for how to do this. We have our lower value is 25. Our upper value, random big number. Our mean and standard deviation were given. And we'll get our final answer of 0.110. All right, for part B, what is the mean of the sampling distribution of X bar? If you look back to your notes, I told you that the mean of the sampling distribution is equal to the mean of the population, which is 18.5. Not bad. Okay. For question C, it's asking us to calculate and interpret the standard deviation of the sampling distribution of X bar. Verify that the 10% condition is met. Okay, so 10% condition, let's see. If now we're choosing a sample of 10 US teens, is 10 less than or equal to 1/10 of all teens? Yes, it is. 10 is a relatively small sample based off of a very large population. Okay, so that's all we needed to do to make sure that the 10% condition is met. Great, okay. So now we're finding the standard deviation. This is the formula that I just gave you in your notes. So standard deviation for the distribution is equal to my standard deviation for the population divided by the square root of my sample size. So that's going to be 5.3 divided by square root of 10, which gives you 1.67. All right, now we have to interpret it. How many of you guys actually did that? I won't know, but hopefully some of you did. Okay, so I'll put it down here. The mean number of minutes spent watching YouTube in a sample of 10 US teens typically varies by 1.67 minutes from the mean of, what was my mean? 18.5 minutes. All right, and then last question for part 1. Find the probability that the mean amount of time spent watching YouTube for the teens in the sample exceeds 25 minutes. Okay, so I'm going to go ahead and erase this text. So if you need it for a minute, hit pause. I just need more space to work. All right. I'm gonna go ahead and draw out my normal curve. Now my mean is still 18.5. I'm gonna label my mean and my standard deviation. And then we're looking for what's the probability that the mean of a sample will be greater than 25 minutes. Okay, so I'm gonna go ahead and use normal CDF. My lower is 25, upper, random big number, mean and standard deviation, we know. Okay, and then let me see what we get for that. If you round it a little differently, you'll end up with slightly different things, but we should be pretty close. All right, so I'm getting a super, super small number. Hopefully you are too. I'm just checking because this looks a little different from my key, but I think I just did it in a different way. Yeah, well, my probability here is I have, my calculator is telling me 4.96 e negative 5. So what that means is I'm going to move this decimal point to the left 5 times. So 1, 2, 3, 4, 5. Let's see how many zeros I get there. 1, 2, 3, 4. All right, so I've got 0.00005 basically. So like super small. One thing I want to talk about just briefly is why this probability is so different from what we got in A. So the difference is that in A, we were just choosing one person, and like the chance of randomly choosing one teenager who watches a lot of YouTube is like, I don't know, decent. But then the difference is that with D, we have a random sample of 10. So then it's like, we're not just finding one person who watches a lot of YouTube, we're sampling 10 people and the mean is high. So that means that like all 10 of those people on average would have a pretty high YouTube minute count. So that's why our probability is so much less for D. All right, so that's it for part 1. Yay. Go ahead and make sure you have all that stuff done and start part 2 when you're ready.